Previously, you've always dealt with systems that have linear equations. So all of them have an exponent of 1. But what if we have nonlinear? So take a look at this first one. We have x squared equals 2y plus 10. And 3x minus y equals 9. So we have a quadratic and a line. So what I've noticed when I look at this is that the second equation, I could solve for y pretty easy. So I'm going to take that second equation and get y by itself. So I may add y over and subtract the 9 to that side. And now I have an expression for y. So in the other equation, I can, let me get a color here, take the y in that first equation and replace it with what y is equal to. So we're using substitution. So I'd have 2, and then instead of y, I'm going to put 3x minus 9. And then there was a plus 10 at the end. So the next thing I would do is distribute. Now I've got a quadratic. So I'm going to get everything on one side set equal to 0. Two things that multiply to be a positive 8 but add to be a negative 6. That'd be negative 4 and negative 2. When I set each one of those equal to 0, I get x equals 4 and x equals 2. Now, it is possible to have two solutions to this. Think about it. If you have a quadratic, whether it's opening up or down, and I have a line, it can actually cross twice. So I have two different values for x. So I need to find the points. So I'm going to take x equals 4 and plug it into that expression. I could plug it into either one, but I like that one. So if I plug in 4 to that, 3 times 4 minus 9 is 3, so I have the point 4, 3. The other point has an x value of 2. So 6 minus 9 is a negative 3. So I have the point 2 comma negative 3. So there's 2 points for our solution. Oh, wow, that's a circle, isn't it? So x minus, the center would be 2, negative 3 with a radius of 2. So I have a circle and a line. So a circle and a line, you could either have it not hit it at all, it could hit at 1 point, it could hit at 2. So we have a lot of options. I'm going to solve this one. I like to solve for y. Okay, so we'll solve for y. Add the y over, subtract the 3. And now I have an expression for y. So what I can do is I can take the expression that y is equal to and replace y with it. I could have solved for x just as easily, but I just wanted to do y because, well, just kind of made things easier, because when I did that, look what happens in that parentheses. X minus 3 plus 3. So this was the expression x minus 3 that came from the substitution. Now I will need to multiply this out. So I need to remember that's x minus 2 times x minus 2. X squared minus 4x plus 4 plus x squared equals 4. Come on in. And now we would combine like terms, get everything on the left side. So I'd have to subtract 4, which is kind of nice because those 4s would cancel out. Then factor out a 2x. Set each equal to 0. And again, we get 2 x values. Now we need to find the y's that go with them. So I'm going to plug back into that equation. If I plug in 0, I get negative 3. So we have the point 0, negative 3. And if I plug in 2, I get negative 1, so the point 2, negative 1. On these next examples, you could do substitution or elimination. What if I take that second equation and multiply it by negative 1? I would get negative x squared minus y squared equals negative 10. Add them together, divide by 3, and I get x equals plus or minus 1. I have two different x values. So I'm going to give myself a little bit more room here. So x equals 1, x equals negative 1. I can plug that back into either one of these equations. I like the bottom one. So x squared plus y squared equals 10. I end up getting two y values. Well, there's 2 points. What happens if I plug in negative 1? Well, negative 1 squared is also 1. I get 2 more points. So this is interesting. We get 4 points of intersection. So let's look back at what we had. So we have a circle, and this actually would be kind of an oval if you looked at it on the graph. So if I have a circle and an oval, yes, we could get 4 points of intersection. All right. So I could substitute for y, but then if I square it, I'd end up like with a x to the 4th. I'm going to do something interesting on this one. You could do elimination and get this x squared. Actually, that's what I want to do. If I move the x squared over to the left side, it would be a negative x squared plus y equals 3. If I add the bottom equations together, the x squareds would disappear. But be careful here, that'd be a y squared plus y equals 12. Ooh, it factors. So I end up with 2 values for y. Let's plug those values back into any of the equations. I'll probably pick the first one. So this is y equals negative 4 and y equals 3. Uh-oh. These are imaginary solutions. That's not what we want. If I plug 3 in and subtract 3, I get 0 equals x squared. So x equals 0. So this one actually ends up only being 1 point of intersection.